Good morning, students. Okay, in yesterday's class, we have solved some problems, correct? In today's class, let us solve some more problems. Okay, in yesterday's class, we solved some of the problems on this chapter. In today's class, let us solve some more problems. Okay, from question paper. Let us solve some of the problems from question paper. Okay, the first problem, let me take is somewhat like this. Let me write problem number 1. Okay, no problems. But this is part 2 class. Remember, this is part 2. Okay? Now, problem number 1. Two thin lenses of power plus 1.5D and 1.5D and minus 0.5D minus 0.5D are kept in contact. Are kept in contact. Or kept in contact on their principal axis. Principal axis. On their principal axis. What is the effective power? What is the effective power of the combination Okay, let me mention the year March 2018. March 2018. For 1 month. Simple problem. For 1 month. What is given? See, we are given two thin lenses of power plus 1.5D and minus 0.1 are kept in contact on their principal axis. What is effective power of combination? Very simple. Effective power P is equal to, okay, P1 plus P1 plus P. For 1 month, no what steps, all these things needed. Directly you can do it. Okay. Here P1 is equal to plus 1.5. P2 is equal to minus 0.5. See here, this is plus, this is minus. Why? You know. Okay. What's the meaning of plus and minus? Okay. Let me write now. P is equal to 1.5 minus 0.5. P is equal to 1 diopter is very simple. For 1 month. Okay. Let us consider the second problem. Okay. Okay. Don't waste time. Let's consider second problem. Problem number 2 is somewhat like this. Problem number 2. I will write from, okay, visible. A small bulb is placed at A bottom of tank containing water. Tank containing water. A small bulb is placed at the bottom of a tank containing water. Fine. To a depth of 1 meter. Full stop. Okay, correct. Find critical angle. Find critical angle for water air interface. Also calculate the diameter of the circular patch. The diameter of circular path they have given. But it's patch. 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 Circular patch of light formed on the surface of water. On the surface of water. On the surface of water. What is given? Differential index of water is given. I of water is equal to 4 by 3 they have mentioned. Instead of giving 1.33, we are given value in the form of 4 by 3. What exactly is the question? Please see the problem carefully. A small bulb is placed. Here you are supposed to take bulb as a bulb is of 0.6. Very small bulb. At the bottom of the tank. Okay? Let this be water tank. Okay? Water is not visible. So this is not visible, correct? Fine. No visible. A bulb is kept. Let me draw a small bulb here. Bulb is kept at the bottom of the water tank. At the depth, this height is h. Say h is equal to 1 meter. At the height of 1 meter. Find the critical angle. Okay? Somewhere here I will write. Find the critical angle. You have to find critical angle for this is air, this is water. Water interface. And find circular patch of light forming. What exactly is this? Let me explain. This is the reference point source, say bulb. This is water, this is air. Here we have given the current index of water as 4 by 3. This is given question. Okay. Nothing else is given. Only one data is given. See. First point is your point source is in water. Water means compared to air, your water is denser medium. A ray of light which is incident normally on surface of water will move without any deviation. Okay. First, a second ray which is incident actually there are number of rays. Let us consider only three rays. A second ray which is incident at an angle which is equal to critical angle IC. Here, ray of light, refracted ray of light, will pass without any deviation. So, R will be equal to 90. Then, your angle of incidence will be critical angle. Hope you understood the problem. See, we have number of rays, beam of light. Let's consider this thing. We have to calculate what critical angle. Let us consider a ray which is incident at an angle R is equal to 90 degree. I mean, refracted angle is exactly equal to 90 degree. This is possible only when your angle of incidence is critical angle for given pair of media. So this is IC, this is normal. Okay, let me grab this portion. This is R. This is refracted ray along the surface separating air and water. You can consider one more ray here also. No problem in that. Okay. One more ray here. Moving like this. It will also graze along the surface. Okay. Let us draw a normal. This angle will be 90 degree, which is equal to R. This angle will be ultimately angle of incidence. See here, if this is IC, critical angle, then this will be IC. Correct? If this is IC, this will be IC. If this is angle, critical angle, this will be angle will be also critical angle. Z shape. Okay, understand? From this point to this point, a circular patch of light is formed. A circular patch of ಬೆಳಕಿನ ಸೋರ್ಸ್ ಕೆಳಗಿಟ್ಟಾಗ ಅದು ನೀರಿನಿಂದ ಯಾರಿಗೆ ಹೋಗುವಾಗ you observe a circular patch. In circular patch here. This is circular patch. Capital. And this distance will be radius. This is whole distance from this point to say this point A, this point B. From A to B, it is diameter. Then this half of diameter will be radius. You are asked to calculate what? You are asked to calculate diameter. Let me write D is equal to question mark. You also calculate what? Calculate what? Diameter of circular patch. Diameter of circular patch. This is geometry behind your question. It's a simple question, no doubt in that. Okay? Remember, this distance is h now. And this is h. This distance is h. This distance is r. Where r stands for radius. From this say O. From O to B, the radius. O to A, the radius. O to this point of the luminous point of say some x, whatever it will be. This OX will be h. OX will be h. Okay. First point you are asked to calculate. You are asked to calculate what? Critical angle. When object is placed, luminous object is placed in a denser medium and rays are allowed to pass from denser medium to rarer medium, what is the relation between critical angle and angle of incidence? I mean critical angle and refractive index. critical angle and refractive index. 1 second. I will keep it out. Right? We know refractive index N is given by 1 divided by sin IC. During our theory class, we have proved this equation. We proved this. And there I mentioned this will appear in what? While solving the problem. See, we have to use this equation. This IC we don't know, but N is given. So I will cross multiply. I will write it as sin IC is equal to 1 by N. Look carefully. Easy problem. But you have to look it very carefully. Or sin IC will be equal to 1 divided by, it's given somewhat 4 by 3. Correct? This is what we are given. Refractive index of water. Now, sin IC, where IC stands for critical angle, sin IC is equal to 3 by 4. Correct? If you take reciprocal of this, it's 4 by 3. You can take into numerator 3, numerator 4, denominator, because it is 4 by 3, 4 by 3. Here it will 3 by 4. You know this mathematics of or sin IC is equal to 0.75, right? 0.75. Simple calculation. We want IC, critical angle. IC will be equal to sin inverse, you know this by your mathematics. Sin inverse, it is an inverse function. Sin inverse of 0.75. Let me take 0, 0. Why 0, 0? We have to get this value by using the log table. This is log table. Correct? You will be supplied in examination hall. In exam hall, they will provide this, where you have some direct sine, cosine, log, antilog. You can use this. So sin inverse. Okay, 1 second. Moisture. Natural sine 0.7500. 7500. Where is 7500? 7501 I have. So 48 degree. Okay. Just try in your home. Okay, it's very easy to see. So IC is equal to 48 degrees. 48 degrees. Let me write 35 minutes. This is the value of I. What is value of IC? Value of IC is 48 degree 35. 48 degree 35. Correct? First part is good. Second part, what you want to calculate? You have to calculate diameter. Now, okay, one more value is given h. I forgot to mention. Height is also given. This value we want. We want this value, correct? Why? If you know r, you can double it. When you double it, you get value of d, which is the diameter. R is radius. We know this value. What? H. Already we know IC value also. This IC is known, H is known, R is unknown. Why we need R? R is radius. This radius is 2 times of your diameter. Correct? If you know R, you can calculate diameter. You are asked to calculate diameter. Find diameter. They have asked. They have asked to calculate the what? Diameter. Okay. Now, this by this, we can use easily tan theta. What is tan theta? In this case, see, this is IC, which is known here, will be, this is what? Theta. Tan IC, tan theta will be R by H. Hope you understand. Tan theta will be R by H. In place of theta, we have IC. Tan IC will be this R by H. This R by H. Opposite by H. You know it. Tan IC will be R by H. Here, IC is known, so we can find tan IC, no problem in that. H is given in the problem as a 1 meter, then definitely we can find R. Okay, this is the idea behind this problem. Or R will be equal to, where R is radius will be equal to tan IC into H. Or R will be equal to visible? No. Last line I can write, okay? Tan angle is here, IC 40 degree. I will write somewhere here better. See, R is equal to tan 40 degree 35 degree into H is 1 meter. It is given in assignment only, no need to convert. Okay. Now R is equal to, once again we need this tan. You with the help of your log table only. This is tan 48, right? Let's once again try to find tan, natural tangent. One point 343. 1.343. Okay, degree. 36. It is 1.343. 343 into 1. R is equal to 1.34 meter in SI. 1.34 meter. Okay? This is diameter. Radius. What is the diameter? Diameter will be equal to 1.34 into 2. Okay? This is 1.134, 1.134. Sorry. 1 second. 1 second. Oh, glasses. This is 1 second. This is 1.134. 1.134. Okay. Just okay. This is correctly 1.13 into 2. So D is equal to 6 2 into 2 meter. This is the value of 2.26. Okay. In this problem only, you may ask to calculate, instead of diameter, you may ask to calculate area. Area of the circular patch. Area of the circular patch. Okay? One second. See, this is 1.134. One is not printed very neatly, okay? But it is 1.134, okay? And I forgot, okay? Some I also. D is equal to 1.13, just do 4 into 2, what is 2.26. That. If I are asked to calculate radius, area of circular patch, what to do? Simple. Calculation up to R is same. Calculation up to R is same. Then you may ask to calculate area of circular patch. Then area will be equal to R square. You have to apply this formula and find expression. Hope you understand. Okay. If area is asked, of course, area of circle is pi r square. You have to use pi r square. This equation, this formula, and find area. Okay. Make the square. Oh. Next problem. The previous problem was taken from model question paper 2. Model question paper 2 for 5 marks. Remember, in our question paper we have A, B, C sections. Correct? From problem number 33, from problem number 33, 34, 35, 36, 37, 5 problems, okay, will appear in the main exam. I am talking. In 5 problems, you have to solve any 3. Okay. If there is no question, any question for 5 marks from this chapter, then definitely there will be one question on. There will be one question here, where in problem section you are supposed to solve problem. Okay. Now I am talking about MQP2. Our department has given 6 model question papers long back. This was a question appeared in model question paper 2. This is there in model question paper 2 according to this handbook. Okay. Problem number 3, of focal length, 2 thin lines of focal length 0, 2 thin lines of focal length 0.2 meter, 20 meter actually, 20 meter and 0.30 meter are kept in contact, or kept in contact. Find the focal length of combination. Okay. Question. Find the focal length of combination. Find the focal length of combination. Calculate power of 2 lenses. Correct? Calculate power of 2 lenses and combination. Okay. 2 lenses and combination. March 2014. March 2014. Of course, my friends. Question is, two thin lenses are kept in contact. Okay, a focal length 0.20 meter and 0.30 meter. And write solution. Or you can write given whatever it may be. Focal length of first. Or you can write given whatever it may be. Focal length of first lens is 0.0020 meter. Focal length of second lens is 0. Focal length of second lens is 0.30 meter. You have 30 meter. You have to find equivalent focal length F. What is equivalent focal length? And power of first lens, power of second lens, and power of combination. These are things we are supposed to learn. Which formula we have to use? Of course, two thin lenses kept in contact. We know formula for two thin lenses kept in contact is given by 1 by f is equal to 1 by f1 plus 1 by f2. We know this. Or 1 by f is equal to 1 divided by 0.20 plus 1 divided by 0.30. What next? Take calculator. 1 divided by 0.20, get the answer, plus 1 divided by 0.30, get the answer, add them and take reciprocal because it's 1 by f. We need value of f, not 1 by f, and get the reciprocal. Okay. Without using calculator, is it possible to do? Let's try. 1 by f is equal to 1 divided by, let me write 0.20 as 20 by 100. Right? We can write like this. If you divide, once again you get what? 0.20 only. 0.20 only. 0 will get cancelled. 10, 0.20. Correct? Or 1 divided by what? 30 divided by 100. Correct? Next. Just one effort. Okay. 1 by f is equal to, okay, this 100 by 20. Correct? It will appear in the numerator. Plus 100 by 30. Cancel. 1 by f is equal to, this is 6. 3, 6, correct? SN is 6. SN is 6, this is 2, this is 3, 10. 6. 2 3s are 30. Plus 2 3s are 30. 3 2s are 20. 6 by 3. Correct? Or 3 by 25. Or here let me use calculator. 25 0 point f is equal to 0.12 30 0 point, okay, this is 30 1 5 2 f is equal to 0.12 meter. Effective focal length will be 0.12 meter. Effective focal length will be 0.12 meter. Okay. This portion is over. What about the P1 now. Okay, I will get this problem only. Okay, right here. P1. P1 will be second part we are solving. P1 will be equal to 1 by F1. 1 divided by F1, 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 okay. 0.20, same thing. 1 divided by 20 by 100, 100 by 20, okay. That's 100 by 20, 5. Diameter is a focal length, I mean, power of first lens. Now, no option. Order of what about P2? Same P2 will be equal to 1 by F2. Why I have done this formula? Hope you understand. Yes, the power is numerically equal to reciprocal of focal length, correct? Power is equal to reciprocal of focal length. That's why there is formula also in our theory class, correct? Okay. 1 divided by 0.30 is equal to 1 divided by 30 by 100 or 100 by 30, okay, or n by 3 is equal to 3.3333, like we make it 3.34. This is first lens, this is second lens, correct? Now, what is the combination or combination of both the lenses? Effective power P is equal to P1 plus P2, which is equal to this is 5D plus 3.34D, which is equal to 8.34D. Is the required answer. Is required answer. P is equal to 8.34D. Is required answer. Correct? This is problem number 3, probably correct? 3. Okay. Now, problem number 4. A prism of angle 60 degree a prism of angle 60 degree produces angle of minimum deviation, angle of minimum deviation, angle of minimum deviation of 40 degrees, of 40 degrees. What is the refractive index? What is refractive index? Calculate angle of incidence. Calculate angle of incidence. July 2014. July 2014. Okay. Let us try first what given this solution. Angle of prism A is equal to 60 degree. Angle of the minimum deviation dm is equal to 40 degree. Simple problem, very simple problem. What will you get? What is the refractive index? N you have to calculate. Refractive index of prism with respect to yeah. Also angle of incidence. Which formula? Simple. The refractive index of a prism is given by sin A plus dm by 2 divided by sin A by 2. These are all direct substitution formula. Nothing to just put the value and simplify it. Or n instead of n to 1 let write to n, no problem. N is equal to sin A 60 plus 40, n is 40 divided by 2 divided by sin 60 by 2. Correct? This is sin 60 plus 40, 100 divided 2 sin 50. N is equal to sin 50. So A sin is equal to sin 30. We know sin 30 is 1 by 2, it is equal to 0.5000 in terms of logarithm. What about sin 50? Let's see. It's again natural sin derivative. Sin 50 sin 50 is n is equal to 0.7600. It is 0.7660 divided by that correct directly I know sin 30 0.5000. Let's simplify. Without wasting time, let me use calculator now. This calculator, okay, simple calculator of course. 0.7660 divided by 0.5. 1.532. It shows 1.532. N is equal to 1.532. This is the value. What is unit? No unit. Refractive index is the number, no unit. Okay. This is first part. In second part, what we will calculate? In second part, we have to calculate what? In second part, we will calculate angle of incidence. See here, visible eye we have to calculate. We know while deriving this relation, n is equal to sin A plus dm divided by 2, we came across this formula. I is equal to A plus delta m and dm divided by 2. Let us use this, you will get the equation, required answer actually. This is 60, this is 40 divided by 2. So your I will be 100 by 2, 50 degree. This is required answer. Very simple. Remember problems in case over the main exam, or very simple. See, probably I am drawing your view. This is ideal, very simple. Try to solve all the problems. Okay? Okay. Probably last problem. It's already 45 minutes. Last problem. Okay. We will use a calculator on those things. Let's finish. The radii of curvature, problem number 5. Radii of last one. Curvature. The radii of curvature of two surfaces of two surfaces of convex lens is 0.2 meter and 0.22 meter. See here, this is R1, this is R2. They are not equal. One is 0.2. There is no variation in R2, 0.22 meter. Okay, this is remember. What next? Find the focal length. Find the focal length. Find the focal length of the lens. If Ri, I mean directly right, Ri is 1.5. Find the change in focal length. Sorry, it's quite big problem. Find focal length of lens when immersed in water. When immersed in water of Ri 1.2. Okay. Here you have to find change in focal length. First case, focal length of a lens when it is kept in A. Second case, when same lens is immersed in water. Immersed means put inside the water. Then, in case second case, the rubber medium will be water and the denser medium will be glass. In first case, the rubber medium will be air and your denser medium will be glass itself. Okay, typical problem. Okay, here just for you to mention, July 2018. Okay. Solution. We are given R1 0.2 meter. Okay. This is lens. Say this is R1 0.2 meter in the direction of light. What about R2? This is R2. What about R2? R2 is equal to 0. One second. 0.22 meter. I will draw here. This is R1, 0.2 meter. If it is so, what about R2? R2 in this direction. This is the incident ray. So the R2 will be negative. Hope you understand. R1 is positive, R2 is negative. You can exchange R2 is equal to R1 is negative. That's it. So this will be minus 0.22 meter. Focal length refractive index of glass is given Mg 2.5. Refractive index of what is also given 1 point. Okay. Case 1. When your lens is in air, then you have to find focal length. Its focal length. When your lens is in air, then its focal length. 1 by W is equal to what's the formula? N21, sorry, N21 minus 1 divided by R1 minus 1 divided by R. Here 1 by K is equal to, this is N2 by N1. Let me write in this fashion only, it will be helpful to understand the problem. Minus 1, why? We can write N21 as N2 minus N1. Once again, by theory, we know this. By theory, we know this. 1 divided by R1 minus 1 divided by R2. Okay? One by FK N2 refractive index of glass. Refractive second medium is glass. First medium is 1.5 divided by refractive index of N is 1. Don't write this. Minus 1. 1 divided by 0.2. Here we have minus. Okay. So I will write it as plus 1 divided by 0.2. Correct. 1 divided by A is equal to, this is 0.5. Let me write direct answer. Okay. By using calculator. For LCM, 0.2 into 0.22 LCM. Here 0.22 plus 0.2. Hope you understood. Now you have to multiply, right? 1 by A is equal to, we will multiply here. 0.21 divided by 0.044, 0.044. Correct? Just calculate it. Okay. Or FPA will be equal to 0.044 divided by 0.41. So, okay. This will be visible. This will be Fa is equal to 0.044 divided by 0.04, 0.2095, 0.2095 meter. 0.20 meter. This is the focal length of your lens in here. Somewhere here I will write. FP 0.20 meter. Okay. Now, case 2. Okay. We are running out of time, right? Case 2, problem number 2. Case 2. In water. In water. 1 divided by focal length in water. Refractive index of glass with respect to it. Into means glass. N1 minus 1. 1 divided by R1 plus 1 divided by R2. So 1 divided by is equal to N2 here is plus 1.5. What is N1? Refractive index of water 1.33 minus 1. Once again 1 by same 0.2 plus 1 divided by 0.22. Correct. Next.